Hello friends and welcome to edupediaworld.com, your destination to online education. Friends, as we have learned about the discovery of electron, proton and neutron, so today I am going to discuss with you the discovery of nucleus by Rutherford's scattering experiment. But yes, before starting with the new topic, we have to revise the last sessions. In this review session, what I have done is I have taken all the three discoveries together so that you can understand it more effectively, the structure of atom and the discoveries. So let's start with the review. Here I have taken the example of carbon atom, where proton and neutron and electron are there in their places, where proton and neutron are the center of the atom, electron which is revolving around the center of the atom with the sixth circular path, we call it orbit. So about the discoveries, if we understand, the electron was discovered by J.J. Thomson through discharge tube experiment. The charge was the negative charge and the magnitude of the charge was 1.6 into 10 to the power minus 19 coulombs, and the mass was 9.108 into 10 to the power minus 31 grams. We also understood about the discovery of proton, where Goldstein discovered the proton with the discharge tube experiment. But yes, with the perforated cathode electrode, that is, the cathode electrode was having a holes within it, he understood the charge that the proton are the positively charged particles with the magnitude 1.6 into 10 to the power minus 19 coulombs, and the mass which is 1.672 into 10 to the power minus 24 grams. We also learned about the discovery of neutron, where James Chadwick, learned about the neutron by bombardment of beryllium with the helium nuclei together, and the charge which he found was the neutral, that the neutron is having no charge, and the mass was the same as the proton, that is 1.672 into 10 to the power minus 24 grams. As after the discovery of electron, proton and neutron, it became clear that an atom is made up of these three fundamental particles. Many experiments were then carried out to find out how electron, proton and neutron were arranged in an atom. So how the proton and neutron, and why the neutron and proton are there in the center of the atom. So let's find with the new session, the discovery of nucleus by Rutherford's scattering experiment. Today in this session we are going to learn about the experiment and the atomic model of Rutherford. In the scattering experiment we'll be learning about the experiment, the construction of the experiment, working, explanation and the result of the experiment. In the second part we'll be learning the atomic model, that is the properties of atomic model and the drawbacks of Rutherford's atomic model. So let's start with the session. Rutherford scattering experiment by Ernest Rutherford. We also call him Lord Rutherford. In 1911, Lord Rutherford, a scientist from New Zealand, directed a stream of alpha particles towards a very thin, that is 1/millionth of a centimeter, gold foil to discover nucleus. So he is the man behind the whole experiment and the discovery of nucleus. So let's start with the experiment first, with the construction. Here you can see this figure. This is the experiment, that is this is the equipment, or you can say apparatus, used to discover the nucleus. Let's take a marker and understand the whole experiment. See friends, this is the As you can see, this is a detecting screen. We also call it geyser counter, right? This is a space between the detecting screen which helps to enter the alpha particle rays. So what is alpha particle basically? Alpha particle is nothing but a doubly charged helium ion. That is this one. This contains 2 proton and 2 neutron, right? So this is the figure from top to bottom of the rays passing through the gold foil. This is the gold foil, and these are the rays coming from the alpha particle emitter, right? This is the emitter. This is the gold foil, very thin foil. We also call it gold leaf, right? So this is the whole construction of the experiment. So now let's understand the working, how the experiment works basically. So I should make a diagram of this so that it will be more understandable for you. So this is the gold foil, right? Gold foil with the positive charge within. That is the center of the atom. And here lies the negative charges circulating the center of the atom of the gold foil, right? So here is the detector. These are the alpha particles. Alpha particles are basically positively charged particles, positive rays you can say, right? So I'm making like this. So from here the beam of alpha particles this is the one first ray, small. There's one more which is going straight, right? This is one more which is again deflected. From here it is again deflected. If we strike the center, it is reflected more. That is turned back. So it is the deflected one that is turned back. It is a large deflection, right? This is the nucleus. These are the basically atoms of the gold foil, right? These are the alpha particles. So this is a whole diagram if you see from top to bottom, and most of the beam goes straight. Beam of alpha particle light goes straight without any reflection. So here you can see there are the 3 types of rays, one going straight, one giving a large deflection, one is turning back. So if we understand what happens actually? There are the three kinds of rays. One turned back, right? One deflection, having a large deflection. Third is having a straight line, that is no deflection. So these three are the observations, that the most of the alpha particle went straight through the foil. Some of the alpha particle was slightly diffracted from the straight path, and very few particles, that is alpha particles, were either deflected by very large angles or completely bounced back, right? So this is the whole working of the experiment. So now let's explain one by one what happened actually. The most of the alpha particles passed straight through the gold foil without any deflection with the original path. A few alpha particles are deflected through the small angles and a few are deflected through a large angles. Third ray, which was understand that there are very few alpha particles completely rebounced on the hitting the gold foil and turned back on their path. As if we explain by this what happens actually in this construction, or this, you could say the experiment, that the gold foil is made up of an atom. If the atoms were solid throughout their volume, then every alpha particle striking them should have changed its path and got deflected. Since most of the alpha particles pass straight through the gold foil without any deflection, it shows that there is a lot of empty space in an atom. So we know that similar charges repel each other. So a positively charged body will repel another positively charged body. The observation that some of the alpha particles are deflected through a small or large angle shows that there is a center of positively charged particles in an atom which repels the positively charged alpha particles and deflects them from the original path. So the center of positive charge in an atom is known as nucleus. Thus, the scattering of the alpha particles by a thin gold foil shows the existence of positively charged nucleus in an atom. Third, we understood that the very few alpha particles completely rebounced on hitting the gold foil and turned back on their path. So, this fact cannot be explained only on the basis of repulsion due to positively charge of the nucleus. It can, however, be explained by assuming that the nucleus is very dense and hard. So the observation that a few alpha particles completely rebounced shows that the nucleus is very dense and hard, which does not allow the alpha particles to pass through it. Since the nucleus is very dense, practically the whole mass of the atom is centered in its nucleus. As the number of alpha particles which are deflected is very small, we conclude that the size of the nucleus must be very small as compared to the size of the atom as a whole. So this was actually the experiment performed by the Rutherford to explain and discover the nucleus of the atom. So the result he get is the first, the discovery of nucleus and the properties of the nucleus. What he observed is the nucleus of an atom is a positively charged. Nucleus of an atom is very dense and hard. Nucleus of an atom is very small as compared to the size of the atom as a whole. On the basis of the experiment of Rutherford to discover the nucleus, he considered or explained or made a new atomic model according to him. So this atomic model is basically called Rutherford atomic model. According to this model, the atom contains a large empty space. That is, this is why most of the alpha particle pass through the metal foil without deviating from their path. Second, here is a positive charged mass at the center of the atom known as nucleus. That which is the entire mass of the atom is concentrated in the center. Therefore, the nucleus is the densest part of the atom. The electrically positive nature of the nucleus is supported by the fact that the positively charged alpha particle approaching the nucleus get deflected. So this proves that the nucleus contains proton. He also narrated that the size of the nucleus is very small as compared to the size of atom. This is proved by the fact that the most of the alpha particle pass straight through the gold foil. We can also call it gold leaf. The electron revolves around the nucleus at the large distance from it. That is in the circular orbit found in the empty space of the atom. He also penned down that an atom as a whole is electrically neutral, as because the total positive charge of the nucleus is balanced by the total negative charge of the electron. That is, the number of proton and the number of electron in an atom are equal. Rutherford's atomic model is similar to the structure of solar system. Just as in the solar system, the sun is the center, having the maximum mass, and the planets revolving around it. In an atom, the nucleus contains the main mass and the electron revolve around its orbit or the shell. The outward force, that is a centrifugal force acting on the electron, balances the inward, that is a centripetal force of attraction exerted on them by the nucleus. This accounts for the structural stability of atom, which is the Rutherford atomic model failed to explain the stability of atom. How? That is, on this basis of the alpha particle scattering experiment, he gave this picture of the atom. That is, he made us understand that this is a structure of an atom with the proton and neutron residing in the nucleus of the atom. Here are the electrons revolving in the circular path, right? So this is the whole picture which he generated by the experiment, but he failed to explain the stability of atom. As according to the electromagnetic theory of physics, if a charged particle undergoes accelerated motion, then it must be radiate energy continuously. So now if we apply this electromagnetic theory to the Rutherford's model of atom, it will mean that the negatively charged electron revolves around the nucleus with the accelerated motion will lose their energy continuously by radiation. Thus, the energy of revolving of electron will decrease gradually and their speed will also go on decreasing. That is, the electron will then be attracted more strongly by the opposite, that is the oppositely charged nucleus, due to which they will come more and more closer to the nucleus by the proton, and ultimately the electron should fall into the nucleus by taking a spiral path like this. Let's suppose this is a positively charged nucleus. and the electron will be falling into the nucleus by this taking the spiral path like this. But actually it doesn't happen. So this should make the atom very unstable, and hence the atom should collapse, right? But this does not happen at all. We know that electron does not fall into the nucleus of an atom. Rather, the atom are very stable and do not collapse on their own. So here there was a drawback which Rutherford failed to explain the stability of electron by his experiment. So here I end up with this session with the drawbacks. So there must be some experiment which has been done by some scientists to overcome this drawback, as in order to explain this stability of electron, Niels Bohr, who gave a new arrangement of electron in an atom in 1913, that will be further called Bohr's atomic model. But today I'll be ending the session with your activity. You just have to give me these three answers. That is, the name of the scientist who discovered the nucleus of the atom. Second, what is the nucleus of an atom and what is the nature of the charge on it? And why is an atom neutral in spite of the presence of charged particles in it? So in next session, I'm going to make you understand the Bohr's atomic model, which will overcome the drawback of Rutherford's model of an atom. Thank you. Thanks for attending this session.